Ratnadeep Deshmukh sir. Present. On the behalf of SSBT's College of Engineering and Technology Bambhori Jalgaon, I heartily welcome today's speaker, Dr. Ratnadeep Deshmukh, a senior. Let me introduce Dr. Deshmukh sir, a senior IIT fellow alumni member, presently working as a professor in the Department of Computer Science and Information Technology at Dr. Babasaheb Ambedkar Marathwada University, Aurangabad. He is Principal Programmer Coordinator for DST-FIST program sanctioned by DST, New Delhi. University Coordinator for MHRD Global Initiative on Academic Network Program. He is a fellow member and working chairman of IIT Aurangabad Center from 2014 to 18. Vice President from 2012 to 14. Dr. Deshmukh is a ground level worker of IIT from 1994, key role in enhancing membership as well as upgrading the IIT Aurangabad from sub-center to the full center. He has organized IIT National Workshop and Zonal ISF 2016, working as a coordinator of Maharashtra Rajya Marathi Vishwakosh Nirmiti Mandal Maharashtra Shasan for Information Technology and Computer Science. He is a chairman, Board of Studies in Computer Science Engineering and IT. He is a member of Academic Council, life member of ISTE, IEEE, CSTA, CSI, IDES. He is a senior member of AICTE. He was a member of Management Council and Senate member of Dr. Babasaheb Marathwada University, Aurangabad. He edited 12 books. He has published more than 200 plus research papers in reputed international journals of repute. He is the editor-in-chief of CSI Journal of Computing. He is a reviewer and editor of many reputed journals. He has organized several national and international conferences and also workshops. He visited at University of Santiago de Compostela, Spain. He has delivered number of initiated talks at SFU, Russia. He has visited University of Washington, Seattle and Western Washington University, USA, Shanghai, China, Philippines, Bangkok, Thailand, Uzbekistan for various conferences. He has completed a research project of UGC, DST and received grant of more than 150 lakhs. His area of interest are HCI, DSP, data mining, GIS, remote sensing, etc. He received the Bharat Ratna Mother Teresa Gold Medal Award in 2015 for outstanding service in education and research to strengthen India's unity and economic development. He also received the Best Teacher Award in 2017 for outstanding excellence and remarkable achievement in the field of teaching, research and publication. He also received Best Research Award in the 38th INCA International Conference. He also received the first prize in the Inter-University State Level Research Festival Avishkar in 2009 under HLFA at teacher level for the team management. His profile has been published in the 32nd edition Who's Who in the World 2014, which consists of profiles for more than 55,000 people working in the different areas of around the world. I would like to congratulate Dr. Ratnadeep Deshmukh for his nomination by AICTE in New Delhi as a member of All India Board of Information Technology and Education. Such a high-profile personality is among with us. So we feel very really lucky. Now, with this note, I would like to humble request Dr. Ratnadeep Deshmukh sir to start the session. Please come, sir.
Okay. Thank you, sir. Thanks for a nice brief introduction. First of all, I would like to share my screen. Can I share my screen?
Yes, sir. Yes, sir.
But I think that option is not available to me.
Option is not available.
Ah, yeah. So can you see my screen?
Yes, sir. Yes, sir. Yes, sir.
Okay. Okay.
How, sir? Yes,
See
sir.
my screen. Okay. Okay. So good morning, friends, or good afternoon, friends. Sorry for the inconvenience. But anyway, we are on the track. First of all, I would like to thank the organizers of this 1 week online induction refresher program on machine learning and pattern recognition, organized by Department of Electronics and Telecommunication Engineering. One moment. Engineering, SSBT College of Engineering and Technology, Jalgaon. So I am audible, na? Audible, na? Hello.
Yes, sir. You are audible.
Okay. I'll continue. And welcome to all the participants, those who have registered for this AICT and IST sponsored workshop or program. So today I will be going to share some of the research activities which are going to happen or we are conducting at our department. So first of all, I will like to share my details about the host institutes. I'm working as a professor at Department of Computer Science, Dr. Babasaheb Ambedkar Marathwada University, which is the re-accredited by A grade by NAC, and we are having so many prestigious programs at the university level, as like GAN, RUSA, and we are having a good NIRF ranking, that is 85th rank among the top 100 universities, as well as our university has been established in the year 1958. University is located in the center of the city and having more than 700 acres of the land and 400 plus affiliated colleges, along with more than 4 lakhs students studying in university and affiliated colleges. Okay, so this is about my university, and then about the department. As our Department of Computer Science and Information Technology is the leading department in the university campus, as well as we are having a good recognition at state level as well as national level, with the recognition and collaboration at international level. And I would like to glad to share that my department is supported by prestigious UGC program, that is SHAP, and we have completed successfully SAP 1 phase, and currently we are in second phase of SAP, as well as Department of Science and Technology, Government of India has supported our department under the FIST program, out of which that is near about 1.25 crores of grant has been sanctioned under this FIST program, and I am the principal coordinator for this program. So also, under that program, we have procured, that is the one field spec machine or instrument which is working on the non-imaging spectra or non-imaging spectral images, which costs near about 50 lakhs, procured from the USA, and we are having more than 80 lakhs plus different sort of softwares, licensed softwares, and we have developed a state-of-art research laboratories under this program. So there is one snapshot of GAN program at my department conducted by me and one of the foreign faculty from Southern Federal University of Rostov, Russia, has delivered that program for 1 week under the GAN program. And under this, the infrastructure, I also have visited that Southern University of Russia under this collaborative program, as we are having a MOU with Southern Federal University Russia, as well as Shanghai University Italy, as well as Tokushima University, Tokushima Japan, and also we are having the MOU in progress with the Myco company, which is the international brand of India, and head office is at Jalgaon. So these are some of the pictures where I have visited the Vice Chancellor of the university, as well as Director of the Subcampus of Tagarang, Russia, and the Department of Electronics and Computer Science with Professor Iftekhar. Okay. So friends, these are some of the points which we'll be covering in brief during my lecture. So here, what we are doing. And so at our department, we are having there is more than 10 faculty, there is 12 faculties, and different faculties are working on different research domain, which includes the image processing, GIS, sensing, human-computer interface, speech processing, or speech signal processing, as well as natural language processing, and so on. So this will be the today's agenda for the discussion, and under this DST FIST program, our theme of the program is GIS and remote sensing applications. The particular theme of this field 4 is connected to microwave radiations, as well as non-imaging spectral analysis, or capturing the spectra which are the non-imaging and analyzing the contents of a particular object under that particular equipment. Okay. So coming to our topic, that is as we know, the main source of energy is a solar radiation, light, where the light interacts with a matter in different ways, that it will transmitting through some material or while reflecting or scattering of other materials. Okay, and both the materials and colors, color is referred as a here wavelength of the light affects this interaction. The study of this light phenomenon is referred as a spectroscopy, and basically this equipment works on the principle that is the spectroscopy. So here in this figure you can see that some part of light is being reflected from the surface of object, or some part of the light is being transmitted, or some part of the light is being absorbed, as well as some part of light is being scattered out of this from the surface of this object. Okay. So this ASD field spec 4, this instruments works on this principle of spectroscopy, and it is a line of full range spectrometer which delivers fastest and most accurate spectral field measurements. This ASD field spec is a study of interaction between the physicochemical characteristics and spectral signature characteristics of the object. Okay. And this equipment have been used or can be used for detection or identification or verification or quantification of the object, or the content of the object can be detected, can be identified, can be verified, or can be quantified. Okay, so this is the main basic principle of working or application area of this equipment. And here the spectra which is being generated by this equipment is referred as a non-imaging spectra. So imaging spectra is a different part, and imaging spectra is another part. Okay, so here there are some specifications and details, technical specifications of this equipment. That is, the spectral range of this equipment is a 250 to 2500 nanometer, and spectral resolution is 3 nanometer to 700 nanometer, as well as 6 nanometer to 21 nanometers. And this equipment is having a VNIR detector, SWIR1 detector, and SWIR2 detector, whereas this that is very near infrared detector is having a range of spectral light or spectra that is ranging from 350 to 1000 nanometer, whereas shortwave infrared 1 detector having a range of 1001 to 1800 nanometer, whereas SWIR2 detector is having a spectral range of 1801 to 2500 nanometer. And these are the other technical details of this equipment. So this 350 to 2500 is a vast range or wide range under which we can detect any object or content of any object, or the spectra of any object can be captured within this particular range. Okay. So I would like to share that this equipment is a multidisciplinary, can be referred as a multidisciplinary, and it's having a huge application area. So today I will try to cover up the key areas or most major areas where this equipment can be used, our application area, and how it can be used, and how the research can be promoted, or and that is continued by making the use of the spectral signature out of this equipment. Okay, so the first key application area is a geology and mining. So mining is another part, that is one part, as well as there is a different types of mining, that is industrial mineral mining or petroleum mining, and different finding out different that is metals out of the mining. So here we'll see one video which will explore how this equipment is useful or used in mining area or for mining purpose. Okay.
At AISTE, we have a tradition of expanding the limits of our technology into new application areas. We really have one mission, and that's to make it easier for our customers to use our technology in whatever area of business they happen to be in. We've been doing this for over 20 years now. We've been working in industries related to mining for most of those 20 years. AISTE was founded by geologists and earth scientists focused on applying remote sensing to geology. Today, AISTE customers span 70 countries across industries as diverse as remote sensing, pulp and paper, pharmaceuticals, and mining. To put it simply, we apply near-infrared technology to identify and quantify the composition of many materials, from wood pulp to the mineral content at prospective mine sites, or crushed ore in production. Past 10 years, AISTE's robust, high-performance portable instruments have been used in the field by geologists conducting early mining and mineral exploration. AISTE's instruments are particularly well suited for the rapid analysis necessary to make decisions during metallurgical processes. Our non-contact, non-destructive spectroscopy instruments can simultaneously measure a wide range of ore properties. For example, it can optimize heap leach operations by measuring the abundance of swelling clays, acid consumption, hardness, and total fines. Easy-to-mine deposits no longer exist. Mines want to maximize the amount of extracted metals in the least amount of time at the lowest possible cost. AICTE can provide better, faster analysis of even the most complex deposits to reduce cost and increase throughput by providing better process visibility. The TerraSpec Explorer is a rugged, portable spectrometer designed for mining exploration fieldwork. Applications include geologic mapping, mineral identification, and chip and core analysis. Many mines transmit characteristic wavelength signals that the instrument can interpret as optical spectra. Using the TerraSpec Explorer, geologists can identify key alteration minerals in real time and rapidly map alteration zones associated with porphyry copper deposits. When paired with GPS readings, deposit mapping is even more efficient. The TerraSpec Examiner was designed for lab and production applications such as site mapping, block modeling, ore sorting, and mineral analysis. It leverages traditional sample analysis techniques such as X-ray diffraction, WEM-scan, and wet chemical analysis to quickly analyze a much larger number of samples on site. AICTE's Summit Cal Solutions team is working with mining operations to develop calibration models that leverage lab analysis to produce immediate information about ore samples. Analysis that used to take days now take minutes or less. One copper mine now measures nearly 1,000 samples a day with less than 24-hour turnaround, something never before possible. Analyzing more samples faster means better visibility into mineral processing needs, so the mine can quickly adjust its processes to increase yield and manage costs. What does the future hold for mining as spectroscopy becomes an integral part of nearly every phase of production? The next logical step is bringing the instrument to the conveyor belt to allow real-time measurement of multiple constituents simultaneously for faster, tighter process management. The Quality Spec 7000 is a stationary, high-speed NIR mineral analysis unit situated over the conveyor belt. In copper production, the Quality Spec 7000 is used in agglomeration to optimize acid usage and water addition, resulting in reduced acid costs and increased yield. The Quality Spec 7000 accurately measures non-uniform material containing minerals, clays, and physical properties. This over-the-belt analysis technique is destined to become the new quality and process control standard of the future for globally competitive mining industry. The accurate real-time information produced by near-infrared analysis and the resulting visibility, process efficiencies, and cost savings make it the ideal choice for mining applications. AICTE offers spectroscopic technology, solutions expertise, and the customer service to support it all, from exploration to production.
Okay, so this was the details about how this equipment is being used in the mining area. I think, am I audible? Hello, Zope
Yes,
sir?
sir, you are audible.
But again, what happened? My screen sharing has been on, I think. Okay, I will look. Okay.
Yes, sir, yes, sir.
Yeah,
Now screen is visible now.
yeah. But again, it is going. Yeah. So here we have seen the exploration of that is how this applications of this this equipment can be used in mining area. Similarly, this is most useful in industrial mining as well as petroleum mining. Also, some of the remote sensing and geological applications are being carried out with the help of this equipment. So the second major area where the applications lies, or the advantage can be taken, is the defense and intel. Where in defense, that is it can be the equipment can be used, or the application of equipment can be used to detect the disturbed surface, or this can be that is this with the help of this equipment or the application of this equipment, we can find out the content of the below ground area up to 4 to 5 meters. So if any explosive is being, that is a floored below the ground, that can be detected or identified, where as here you can see, that is detection of disturbed surface, that is hyperspectral sensing is having ability to detect ground disturbances added in the detection, that is buried land and mines and in different places. So also it is having a senior operations like that is the study of that is underwater, that is the scenario of the sea, that is the flow of fishes, or the um, ground level situation underground, and that is under the water, or depth of the water can be measured or identified, and that is detected or quantified by using the spectral signature, and so on. Okay. So this is the environmental analysis or environmental study is a third major area where the that is applications lies there. That is with the help of this equipment we can have study of climate effect or analysis of climate effect, as landscape ecology and ecological uh, research, as well as atmospheric remote sensing research, also ice characteristic research and snow research. So here, under this ice characteristics research, we can check the quality of ice, whether it is having pure water or mixed water, or some that is unwanted elements in the ice, or different sort of related searches in the that is the ice area. And next one, that is fourth one area, is a material analysis, where we can check the quality of the material, as like how the quality control in the pharmaceuticals or pharma industries, or in different material analysis industries is being done. So here we can check the quality of food as well as pharmaceuticals. That is, as we know, on the every that is medicine or pharmaceuticals, the ingredients or contents have been mentioned on that one. That is the calcium content this one, zinc content this one, copper content this one. So we can measure the content of the particular tablet or particular medicine by taking a spectral signature or spectra of that, and we can map whether it is up to the standard or mention on the tablet. Means here we can make a quality control or check the quality of the particular medicine also. Similarly, we can also, that is a measure the quality of any that is pesticides or any cosmetics also. So also we can measure the food quality or quality of the food with the this equipment or this application area. And fifth and last most, that is a application area of agriculture. So here, as our India is an agriculture based country, we are majorly focusing on the different sort of application area related to farming or agriculture related. So here, under this roof, we can do this soil analysis, or plant physiology analysis, or grain and seed analysis, or biomass analysis, or some of the commercial agriculture applications. Whereas this in soil analysis, we can find out all the ingredients or contents of the soil, or we can map that contents, and accordingly we can suggest a particular suitable crop can be taken or will be suitable to take from that soil, and accordingly we can recommend the pesticides to the farmers also. So also we can, with the help of this that is soil, that is vegetation spectral signature, we can monitor the health of the plant, or we can predict the yield of the particular crop in future, and so many sort of application. But at our lab we are very much focusing on the agriculture sort of applications. I would like to share one of the most significant application in agriculture, that uh, now currently there is a system from the government, that is the yearly kharif or rabi, that is farming being done for a particular crop, that is cotton is being showed in a particular area, or how much area is being covered by a particular jowar or maca or wheat. So currently there is system that the talati will that is the farmer has to visit the talati and submit which crop he has showed in his land, and accordingly the complete area is being measured, that is the cotton is covering this much area, wheat is covering this much area. But with of this equipment, if we are having a spectral signature of cotton or any particular crop, we can map this spectral signature with the satellite image, and we can map or measure the area covered under a particular crop by a particular crop, that is area being covered by a cotton, or area covered by a particular wheat, or area covered by a particular plant. So this sort of applications are very much useful for mapping area covered by a particular. So one time, that is before 2-3 years back, we know that in our Maharashtra in India, there was a issue of tur, that is a plant, that is actual showed area was more, but the counted area by our year system or our regular system was different, and that's why this sort of issue has arisen. But this technique can be used to avoid such sort of issues being happen. Okay, so now we'll go to the some technical details, that is how this equipment work, or how that is this non-imaging spectra is being taken, and how this machine learning concept is being utilized in the application of this field spec tool. So the spectra of generated by this equipment is being mentioned in this way, that is reflectance versus wavelength in nanometers. Okay, so in this figure you can see that there is one green line, that is a green grass spectra, or spectral signature of a green grass. Okay, then this brown line is showing a spectral signature of a dry grass, whereas this blue line is showing the spectral signature or spectra generated of a soil sample. So you can here see that what is the that is how this green grass is differing from dry grass. So here at a particular spectra, water absorption area or chlorophyll absorption area or different content absorption areas are being shown at a different spectra. So here you can see that is blue, green, and R, that is wavelengths, lying from that is 0 to 2500. This is the spectral range, and this is the VNRI range, then there is a near infrared range, and there is a mid infrared range, and again the reflector spectra. Okay, so here you can see water absorption area is landing to 0. Or here the tip of this green grass, here you can get the water absorption areas. Okay, so again next we'll see how it is being done. So here is a particular spectral signature of vegetation or green grass or greenery. Okay, so here you can see that in visible range, near infrared or short infrared ranges, this peak are showing, that is the chlorophyll absorption area is being indicated here, whereas these water absorption areas are indicated at these below peaks, and is the reflectance due to spongy mesophyll of the grass or plant. Okay, so this way here we know the plant physiology. Our plant is having a different content in the, that is the leaf of the plant, sorry, leaf of the plant. So here you can see the mesophyll area or cuticle epidermis, or this one, or this is the spongy area. So there are different content available in the plant, and all this, every object or every object will be interacting with light in different ways. Okay, so here you can see that is the from sun or solar radiation will be falling on the leaf, and they will be reflecting in different ways at different place of the particular plant. So here blue, green, red and infrared lights are being appearing or falling on the leaf, and some are being reflected, or some are being that is absorbed, or some of the light is being reflected in different ways at different places. As you see, this is the that is the spongy area, or this is another one, that is palisade parenchyma, or that different places will be interacting with light in different ways. So that particular leaf will be generating a unique spectra, which will be most differing from the other plants. So the spectral signature being captured from a particular leaf will be a unique one, and on the basis of that, the plant species also can be detected, or that is decided or identified, as well as the particular plant species can be differentiated from the other species. In this way, the application of this cotton or area covered by a particular plant I have mentioned, that is very easily possible. That can be in that application, this will be available. So here you can see that reflectance from the green plant leaves will show what it will be showing in the visible region, some part, or some that is objects are being shown at near infrared region or short infrared region. So here you can see that chlorophyll A and B, or carotenoid or polyphenol and so on, are being the main light absorption pigments in the leaf, and this chlorophyll AB A can be, that is absorption area for this chlorophyll A is in between 410 to 430 nanometer, and another range is 600 to 690, where you can find out the chlorophyll A or chlorophyll B on the particular respective bands. Okay, and carotenoid can be found, or reflectance for this carotenoid can be found at 440 and 480 nanometer bands. These bands are appearing in the visible region. And in near infrared region, you can find out the pigments of the leaf and cellulose are in nature, therefore they absorb very less amount of light energy. And reflectance reaches to higher value in the near infrared region because air cell water interfaces are responsible for it. And in shortwave infrared region, we can find out the maximum absorption area or absorption by water content or water, where water occurs at 1450 to 1940 nanometer range or spectral band range. Okay. So here you can see one chart which shows the absorption features of vegetation, or at which spectral band we can find out, or we can get, or we can target a particular chemical or object, that is a chemical content for which we are carving out, or which we are finding out. Okay. So at 4:30. Hello. Hello. I think there is one disturbance or noise. Please mute your mic.
Corrected, sir.
Okay. So at spectral band or wavelength of 430, we can find out chlorophyll A. At 460, we can find the chlorophyll B, or 640 again B, or at 910 nanometer, we can find the protein content, or 1020 protein content, or also we can find out nitrogen content at 1510 or 1690 nanometer, as well as we can find the cellulose or protein or 9. That is, the one particular object can be, or chemical can be find out at a different range, but if we can have a particular range also for getting a particular chemical out of the leaf or out of the any object. Okay. So these are the standard spectral wavelengths, or to get the particular chemical at the particular spectra, that is specific spectral band. Okay. So here again, what we can predict from this vegetation reflectance or reflect, that is the spectral signature of the vegetation or green leaf or green. So we can, on the basis of this, we can predict the grain yield or yield of the grain, as well as growth of plant can be monitored, and we can decide, that is, whether plant is a healthy plant or the stressed plant or weak plant. Okay. In addition to that, we can find out all the chemical contents, as like nitrogen, phosphorus, potassium, which are available in the leaf. So along with this, we can decide the health of the plant, as well as we can detect the disease and its effect on the plant. That is, whether plant is healthy or diseased. Again, the level of disease also can be predicted or can be decided with this study, as well as we can discriminate the different species of the plant. Means that is the one, that is the spectral signature spectra of a particular leaf is a unique spectra, and that will be definitely differing from another spectra or spectra of the another leaf. So on the basis of this, we can differentiate or discriminate the difference between the species. Okay. Or we can identify that is the vegetation species, etc. That is we can identification of vegetation species, that is species, in different ways. Okay. So these are this list of some of the vegetation indices which can be used, or which are being used to find out all the contents, or to map the contents. So I would like to share that this spectra or spectral signature is being converted to the vector form data, and that data can be taken as an input, as well as we can use this vegetation indices to quantify a particular chemical or particular that is ingredient of the object. So this NDVI is one is that is the indices or SR for the to decide the structure of the that is green biomass, fraction, and LAI. Along with that, biochemical pigments can be find out this with the help of this spectra. And here you can see that is NDVI, that is the spectral band R800. This is the band number or minimum and maximum range where the particular object can be mapped. And this is the particular vegetation index. Here you can put the values and quantify a particular chemical which is being we are in needing. So if we want to find the chlorophyll content, these are the vegetation indices. Or if we target the carotenoid, these are the vegetation indices. Or if we want to find out the water content out of the plant, you can use these indices. That is NDIL, MSI, and we can put the values in that. And on the basis of this water content or this chlorophyll content, we can map or we can decide the health of the plant. If the water content are as per standard, or if chlorophyll is desired quantity is there, then the plant can be considered as a healthy plant. And if it is differing, we can that is decide that the plant is not healthy or it is an unhealthy plant. Okay, so this is the way how we can quantify a particular chemical or particular ingredient of the object. Okay, by using the spectral signature. Okay, and here the machine learning concept is most important. Okay, so here this is the spectral spectral signature of a soil. So earlier also we have seen that the spectral signature of the soil, and on the basis of this also we can find out the different chemicals or different ingredients of the soil. So here this abbreviation, that is OM, is a organic matter, whereas OH is a hydroxyl, means again water content and organic matter. On the basis of this, the spectral signature is being captured by the instrument. Again, the spectral range is same, reflectance versus the wavelength in nanometer, and same concept as in vegetation. Okay, so these are some of the factors which will affect the soil reflectance or soil signature or soil spectra. Okay, so here it affects the spectral signature will be affected by the moisture content available in the soil as well as soil texture. What is soil texture? That is whether soil is a sandy soil, slit soil, or clay soil. This also will affect the soil structure. Again, surface roughness of the ground or soil. Okay, or we can find out the iron oxide out of the soil, or organic matter content, or the presence of moisture in soil will decrease its reflectance. And having a low water absorption bands. Okay, so what we can predict from the soil reflectance, that is from the soil reflectance we can estimate water contents in the soil as well as estimate the contents of soil as like chemicals, that is copper, nitrogen, carbon, calcium, potassium, sodium, magnesium, phosphorus, zinc, or whatever the content. We can map or we can find out or we can quantify all the each and every content of the soil on the basis of the spectral signa, that is spectra, and by using the spectral indices. Okay, and we can find the moisture contents along with it. Okay. So these are the some of the that is indices to conquer or to explore the soil or to explore the contents of the soil. That is SAVI, MSAVI or OSAVI. Again here you can put the spectral band range in these formulas and you can map a particular chemical out of the soil or particular chemical ingredients of the soil. Okay. So this is the sample spectral signature of a fruit. So here also you can see that it is being, that is the spectral signature is being showing electron wavelength, and that is the manganese content, potassium content, lead content, zinc content or chlorophyll content, phosphorus content, nitrogen content, sugar, water or protein are being indicated or being shown at a particular spectral band. On the base of this, we can map the freshness of the fruit. So if fruit is kept more number of days in refrigeration, also the quality of the food, that is fruit, will be degrading. And this sort of things can be mapped, that is ingredients of the fruit can be mapped, and we can take a decisions on whether that fruits that is suitable for eating or not. Or so many different applications are there where we can make a study and analysis of the different ingredients of the fruit. Okay, so this is useful in analysis of fruit quality also, or status of the fruit. Okay. So also one of my students has worked on the spectral signature or palm print, that is palm print recognition or palm image recognition. In normal case, that is there is so many work on image processing where we can the work is on, that is we can take a fingerprint image or palm image or different sort of that biometric applications for security purpose. But here also, if your equipment is having a spectral signature of any particular person, and if again that person keeps his hand and take the spectral signature, on the basis of this spectral signature, equipment will recognize a particular person also. So here also, that is the melanin bands are here, that is hemoglobin can be mapped here, or papillary dermis spectral bands can be mapped at this particular ranges. Okay. So in this sort of that is biometric application also, this equipment is can be used. Okay. So where, how this is possible? Because this melanin absorbs in blue light at the particular, you can find it at 470 band, or hemoglobin can be find out at 5 to 640 nanometers, or papillary dermis can be find out at this particular spectral band. Okay. So again, it is a very important that we have to take a spectral signature correctly, and it is a most important part. That is, if you don't able to get the spectral signature correct, then there will be error and your analysis will not be as per the desired, or it will not correct. So there are different factors which affect the spectral measurements. Okay, or spectral. So out of this, the property of target can be chemical and biological properties, and physiological properties, as well as illumination geometry. Here, I would like to mention that this equipment can be used in control condition in lab, as well as this can be used at field, on field. Only we have to change that is the field of view while using this equipment at the that is the real ground, or at control places, or at outside the lab also. Okay. And this calibration of instrumentage is most important. Environmental factors are so much more important, that is humidity, temperature, wind, speed, and direction, and cloud. So after every 1 hour, this equipment has to be that is reconfigured or deinitialized. So as to that is, if we are taking a reading in mile, and that is in the morning, the intensity light or angle of light will be different. At the afternoon, intensity light and angle of light reflector falling on the object will be different, or in evening time. So before using or taking spectra from this equipment, after every hour, the equipment has to be reinitialized or reinstalled, that is started. Okay. So again, that is the viewing geometry. The viewing geometry can be decided where we are using this equipment. If we are using this equipment in control situation in lab, so field of view, that is 8 degree, will be useful or is to be preferred, or nadir view. And if we are using this equipment as on field, then 24 degree field of view is most suitable. Okay. So accordingly, and that is we have prepared this one dark room specifically for this equipment, because uh, basically this equipment works on the light falling, or solar light or light falling on the surface of the object. Then if we are using this equipment outside the dark room, then other light may affect the reading. So in control situation, for getting accurate reading, we have prepared the dark room for this equipment. But instead of that, we can use this equipment on field also at the one place. Okay. So this equipment is a portable also. Okay. So also, that is a wind speed and this cloud cover. If there is no sunlight, again the light intensity will be differing. So again that may affect the spectral signature. Okay. So due to all these reasons, it is required that the data collection or spectral signature collection should be made in a proper way, or in a precaution, by taking precaution and taking in prepare that is proper way. Okay, that is for identification and quantification or quality analysis of any object. Acquisition of correct spectral signature is the most essential part, and proper measurement must be taken while collecting spectral data, because many factors affect the spectral signature. Okay. So these are some of these technical details. I will not go in more details, but I will narrate the steps to take to initialize the equipment ready, to make a equipment ready to take a spectral signatures. So step 1 is a spectrometer warm-up. So before using for taking a spectral signature, this equipment should be started 20 to 30 minutes before. So warm-up time is 20 to 30 minutes. Then after that, laboratory setup of spectrometer, that is field of view, is to be calculated as I have narrated. That is field of view 8 or 24 is to be selected. Then we have to optimize the equipment for the particular current situation. That is intensity light of light, wind speed, and again different affecting factors, cloudy condition. So on all the basis, we have to optimize the or initialize the equipment. Then we have to measure the dark current of the with the help of this equipment. Then we have to take a white reference. White reference means we'll get a straight line of the spectra. That we are getting straight line of spectra means the equipment is ready for the taking the spectra or reading. So or it is a ready for capturing the spectral signature of the material. Okay, after white reference. Okay. So here are the details of how to calculate the field of so those who will be directly going for that, they can go in detail, or I will, if anybody wants detail about this, I can communicate them on mail or separately. So how this field of view is being calculated, that is 8 degree, 0 degree or 24 degree. Okay. So these are the all the details. Due to time constraint, I will not go in details. So this is one of the nadir view, zero view. Okay. This is referred as a nadir position. Okay. So here you can select either 8 degree angle or 24 degree of the field of view. That is, it is referred as a slanted position. Okay. So again, here I earlier mentioned that is we require a RS3 software for taking the spectral signature. So this is the third step, or before third step, that is the RS3 software is being splashed or opened, and then we can start the optimizing the equipment or making ready the equipment. So this is referred as optimization. Here you can see this that is initializing the equipment in third step, whereas the dark measurement current, there are different options, and we can select that, and the equipment will be calculating dark current or optimization, and at last we'll get the straight line spectra. So here meaning is that the equipment is ready for taking the spectra or capture the spectra, which is referred as a white reference reading. Okay. So this overall setup at our lab, we have created a dark current. Here you can see the equipment in spec 4, the light illuminating bulb or stand. The light is falling on the object, that is green plant, and this is the spectral gun or spectral signature capturing gun, which will capture the signature and this signature, and here we can see the readings. That is measuring dark current, optimizing equipment and white reference, and then capturing a particular spectra. Okay, so this is the overall lab setup for this hardware or spec 4 equipment. And here we have created a facility, that is we are having a most costly softwares we have made procured and made available under this project. That is, along with this field spec 4, we are having a ArcGIS software of 10 users license, NV and ERDAS, which are the that is the imaging softwares where we can do work on the GIS and remote sensing application. Along with that, we are having a high resolution printer, which can be used to take a printout of A4 sheet or 1/8 sheet drawing sheet. And for this GIS remote sensing application, we are procuring data from NRSC Hyderabad, which is the national government agency for purchasing or procuring any sort of data. That is, some of the free data is available on Bhuvan, but if we require some specific sort of data or satellite data, that can be purchased or procured from the NRSC Hyderabad, which is a national nodal agency for providing the different satellite data, that is Cartosat or INSAT or this IRS. These are the different satellites launched by the India, and 24/7 they are capturing the data, and latest recent data is not freely available. but we can some of the overlay data is freely available, and if you want to want to use the application that is latest recent data, we have to purchase it from the NRSC Hyderabad. Okay, so that facility is also available. We are the regular customer, that is client, registered client for this NRSC Hyderabad. So this was all about the infrastructure and this facility available created at department. So as our department is having a 4 program, that is MSc Computer Science, MSc Information Technology, MTech Computer Science Engineering, and PhD program, and MPhil. So here different that is MPhil, PhD, and MTech students are working on different application areas at our lab, but we are mostly focusing agriculture related application. So here some of the students are working or have worked. Some of the PhD students are awarded their degrees. Some, that is more than 40 MTech students awarded degree, and more than 20 MPhil students also. And currently some students are working on different varied topics, as like a winter crop discrimination using this hyperspectral remote sensing data, or classification of crop types using spatial and spectral features from this data, and design and development of spectral signature of crop using this hyperspectral data technique for analysis of effect of air pollution on chlorophyll, water, and different contents of the tree leaves using these spectral indices. In addition to the discrimination of leaf nitrogen content, that is concentration in tomato plant, as well as spectral analysis of chlorophyll, water content within fresh and water stressed, or discrimination of healthy and water stressed plant, or detection of pesticide using spectroscopy, or analysis of this 2D4 amine, 2,4-D amine chlorophyll content in wheat and corn, or detection of acid rain stress effect on plant, or estimation of phosphorus contents in the leaves by using a particular vegetation indices, or spectroscopic determination of above ground biomass in grass using these hyperspectral indices, or spectral discrimination of healthy and diseased plant using non-imaging hyperspectral data. These were some of the vegetation related applications, where some students have worked and working on soil related applications also. Sorry. So soil related application, there is spatial and spectral feature extraction for soil type classification from the hyperspectral remote sensing data. Creation of soil spectral library using this field spectra, identification of arsenic content in soil, as well as monitoring hydrocarbon contamination of agriculture soil by reflector spectroscopy, or estimation of soil organic carbon, which will affect the yield of the corn, that is plant. Estimation of copper content using different spectra, or spectral estimation of soil moisture, or soil total nitrogen, lead, nickel contamination, or detection of soil texture, that is decide whether soil is a clay, sand, or slate type, and so on. So also some students are working on biometric sort of applications, fruit related application, and medicinal plant applications also. Okay. So also we are creating a spectral library for different, there is vegetation, soil, and different work area, and we have made this spectral library available to use for further research also, by taking, that is initializing, or by submitting some forms, you can get the spectral signatures also. So different students are working on various crop, fruit, soil, medicinal plant or vegetable, plants, and there is palm print recognition application, and so on. We are creating spectral library of the vegetation and soil. And MTech students are working on different topics. So here I am sharing some of the apps or applications developed by some of the students. And that is, we have almost worked on all the contents of the soil, and we have integrated all these apps together. And now we are in position to provide soil card to the farmer or any customer. So that is how you are getting the Kisan card. Kisan card, you will that is you are getting, that is getting the contents or all these things, soil card. If the sample is submitted, all the contents of the soil can be mapped, and that quality of card can be provided to the customers or farmer. On the basis of that, we can recommend the suitable crops on the particular soil to the farmers. So here, one student has completed his work on spectral estimation of soil moisture content finding by using a particular indices. So these some basic information, that is soil profile, what is soil profile, and this thing. So from the site from where the soil content has been taken, and here you can see that spectral signature of soil sample is a soil type is a loam type, and soil moisture content is having a 14 gram per sample, and there the celestial crop is sugarcane. So in the particular sample, there is soil sample, sugarcane crop is suitable. It is recommended. So in another sample, that is finding out this one moisture content. Here you are getting 5 gram per 100 gram, and the crops suggested are maize and wheat sort of crop. Okay, so this is another top sort of application developed by another student, that is hyperspectral analysis of soil total nitrogen content, finding nitrogen content using a particular spectral indices. So here also you can see the other general information along with the results. So here you are finding out the percentage of nitrate in particular sample is 20 point something, and crop suitable you can take sugarcane or mustard or soybean, jowar sort of crop. In another sample, the nitrogen is 7 point something. So here the recommended crops are mustard, wheat, onion, soybean, cotton. These crops are being recommended for a particular soil sample. Similarly, the other apps also developed for estimation of soil organic carbon contents, as well as spectroscopic determination of above ground biomass in grass to decide the biomass of the grass. That is, if the biomass is more, that sort of blocks can be used as a coal, and if biomass is more, that particular block will be more taking time to complete his that is fire. Again, estimating copper contents in agriculture soil by reflectance spectroscopy and so on. Okay, so there are so many applications or apps developed, and we have integrated all these apps at one platform, and we are in position to provide a soil card to the farmers or customers. So with this, I will come to conclusion that is this hyperspectral remote sensing studies have shown a variety of huge area of applications, including geology, mining, defense, environment, agriculture, and material quality assessment. Here, the selection of optimum waveband to study different applications in census view based on the broad range of the literature reported, and acquisition and understanding of basic spectral signature is very essential in every application domain. Okay. So with this, uh, we are at the end of the session. So before that, ending my session, I would like to make an appeal to the participants, those who have initialized or maybe interested in doing his further research or research in this area. They are most welcome. They are most welcome to our university campus, as Aurangabad is a favorite place for the Ajanta Ellora caves, Bibi ka Maqbara. Along with that, you can visit my department and university, and we can have a collaborative work also, and we will happy to provide some support also of residents at faculty house and all these required things, or share the our that is the research in a different domain. So I make appeal to take advantage of this state of art facility available at our department. So with these words, again, I would like to thank all the participants. Or before that, I will like to answer if any query is there or any question from the participant, because I think there might be some query definitely, or some questions from the participants.
No,
Yes.
participant, you can ask the question. If any participant is having any problem, they can ask the question.
आता सगळ्यांना भूक लागली असेल का? जेवणाची वेळ झाली आहे. But even though if not now, on my this mail ID, if you are having any query, you can send me the query or question. I will try to help out them or resolve the query of anybody. Okay, so if there is no any question or query, I would like to thank the organizers again for inviting me or giving me opportunity to interact with these participants in this prestigious program. And also I would like to thank the patient listening of the participants. I don't know how many and how much the participants have got, because this is a new area, but having a much more opportunities for a future research. Thank you.
Yes, sir.
Yeah, if there is no query, then we can conclude, no? Yeah.
Yes, sir. Yes, sir. So before conclusion, I would like to tell one share to Dr. Deshmukh sir.
Yeah.
हम जीते हर बाजी तो मशहूर हो गए, आपकी हंसी में हंसे तो सब गम दूर हो गए, बस एक आप जैसे सरों की बदौलत हम टूटे हुए कांच से कोहिनूर हो गए.
क्या बात है.
Thank you very much. So on the behalf of SSBT Bambhori Engineering College, I name Kazi extend my thanks to our respected Dr. Ratnadeep Deshmukh. You have covered your topic and very nice interactive session you have taken. So on the behalf of college and ENTC department, I really appreciate your efforts, and whatever effort you have taken, that is appreciable. So thank you very much once again. Thank you very much, sir.
Thank you. Right.
Break. हाँ, एक ब्रेक किया ना, चलो क्या आपका. There is a break. All participants. There is a break of half an hour.
3 o'clock.
We will meet at 3 p.m. Okay. We will again meet at 3 p.m. and we'll start the next session at 3 p.m. So all participants are requested to attend the session at 3 p.m. Thank you. Thank you very much.
Next session, attendance I will take on next session.
The attendance will be taken in the next session at 3 p.m.
Okay.
All participants.
Zope sir.
Yes, sir. Thank you very much, sir.
Okay. Thank you.
Yeah. Thank you very much, sir.
तुम्हाला प्रेझेंटेशन शेअर करता आलं तर करा.
हो सर. सर व्हिडिओ लिंक पूर्ण शेअर करेल मी तुम्हाला.
ओके राईट. थँक्यू.
येस सर. येस, थँक्यू सर.
ओके.
Thank you. Thank you very much, sir.
थँक्यू.
Participant like कोणाला सांगूया मला attendance link जो attendance will be taken.
There is a technical problem in the link actually as far as the attendance is concerned, but attendance will be taken in the next session. So all participants, please don't worry about the attendance. The attendance will be taken at in the session of 3 p.m.